Bismillahirrahmanirrahim. I'm here, Professor Izzat Karnain, with the BS Mechanics, Q.K.GHORI. Okay, and now today we are dealing another example here. Example is a particle moves in a straight line with an acceleration kV cubic. Its acceleration is kV cubic. If its initial velocity is u, it means acceleration is given and acceleration is kV cubic. Initial velocity is u. Find the velocity. You have to find out the velocity and the time spent when particle travel a distance x. It means what do you want? You want to find out velocity in terms of x. You want to find out time in terms of x. Initial velocity is u and acceleration is kV cubic. Another thing I want to tell you. I already told you acceleration formula. Okay, let's see here. You have acceleration formula as dv over dt. Most of the time you use this one. Okay, what I'm doing here, that the dv over dx, I'm dividing x and multiply by dx. It's the dt as it is. This dv over dt as it is, what I have done, I multiply dx and divide by dx. Okay, you know this dx over dt, it's speed. So I can also write this one as dv over dx multiplied by dx over dt. Rate of change of distance is speed. It's not a velocity. Just keep in mind it's a speed. So it means I got another formula of acceleration. That acceleration is equal to v into dv over dx. You can also use this formula. You can also use this formula. Now the question is that when we have to use this formula, I tell you one thing here, that if acceleration is like this acceleration means acceleration is given like this kV cubic. If acceleration is time dependent, then rather than acceleration you can use dv over dt. And if it is not time dependent, let's see here, it's not a time dependent. It's not a time dependent. There is no involvement of time here. Then A will be equal to v dv over dx. So you go to my point, that when acceleration is time dependent, you will use A by dv over dt. And when it's not time dependent, it's independent of time, then rather than A, you can use a v dv over dx. So this A, I can write here v dv over dx. It's equal to kV cubic. I hope so. How I got this A equal to v dv over dx, I explained you here. You can write down these things on your notes, my dear students. Okay, now if you know differential equation, this is becoming here a differential equation. I have to solve this differential equation. For solving differential equation, what I have to do, I have to make first of all its separable form. You know what is separable form? Separable form is like this, that you want a term v with dv, you want a term dx with dx. This is separable form. Okay, just see here, just v cubic, it's multiplying there, it will come here, it's v over v cubic into dv, it's k, this dx will go there and it will multiply there. What I'm doing, I'm just making it separable form. Okay, this v and this can be cancelled. It will be 1 over v square into dv. Here is k into dx. I can write 1 over v square. I can write here v power minus 2 into dv. And here is k into dx. Just see here, this is separable form. Why it is separable form? It is separable form because v is present with dv and x is present with dx. But here is no x, so no issue. If there will be any term of x, that will be present with dx. Okay, now I got this separable form. And when you got a separable form, then integrate it both sides. This is the way to solve a differential equation. Okay, now I'm doing integrating both sides. Okay, I'm doing integration. It means v power minus 2 into dv. From here, k can be taken outside. Here is 1 dx. You know the power rule? Yes, v power minus 2. Integration will be minus 2 plus 1. And here is minus 2 plus 1. K, there is already integration of 1 with respect to x, it will be x, and I can place here capital A. And you know what is capital A? Capital A is a constant of integration, and its value can be found by using initial condition. Okay, we found here. Okay, how we can found here? Now just see here. Minus 2 plus 1, it will be minus 1. It will become v power minus 1 over minus 1 equal to kx plus a. This minus will come here. It will become minus 1 over v. Minus 1 over v equal to kx plus a. I can call it equation number 1. You know what is capital A? Capital A is the constant of integration, and its value can be found by using initial condition. Okay. Where capital A is a constant of integration, and its value can be found by using initial conditions. Okay, what are the initial conditions? Initial conditions means at t is equal to 0, and you know, when motion is started, its distance will be 0. So it means at t is equal to 0, x will be 0. And you know, its initial velocity is u. It means initially at t is equal to 0, x is 0, its velocity, because it's given in the question that its velocity is u. So what I have to do, I have to put these three values in equation number 1. Okay, it will become minus 1 over v by u. K, x will be 0, and it's capital A. You will be getting capital A equal to minus 1 over u. So I got a capital A. Now what I will do, I will put this capital A in equation number 1. Okay, this put A equal minus 1 over u in equation number 1. And what it will become? Minus 1 over v equal to kx minus 1 over u. Basically, what you want a value of v here, because in the question it was asked that find the velocity. So it means you want to find out v here. Okay, what you have to do, just take its LCM. Its LCM will be u here. 1 you will divide here, u will multiply with this. It will become kux minus, u will divide here, it will become 1. 1 will multiply with 1, it will be 1. It will be minus 1 over v. You want to get a v. If you want to get a v, take a reciprocal on both sides. Reciprocal here, reciprocal here. Might be I'll be getting minus v, then from there I will get a v. Okay. Reciprocal on both sides. Okay. Take a reciprocal, it will be minus v equal to u will come in the denominator, kux minus 1. But you want to get a v. If you want to get a v, this minus will go there. V will be equal to u divided by, okay, this is kux minus 1, because I am sending this minus over there, so both signs will be changed, and it will become 1 minus kux. So what you got? You got a v, means you got a velocity. And in the earlier I told you that you want to find out a velocity in terms of x, and I got it. Okay, now I want to go towards time. Okay, you know, this velocity v equal to dx over dt. So rather than v, I can write here dx over dt equal to u divided by 1 minus kux. Again, this is a differential equation, and I want to solve this differential equation. I hope so you studied in differential equation, means in mathematical method chapter number 9, that how to solve a differential equation. First of all, you make it separable form, then you integrate it both sides. And what is separable form? You know, separable form means you want a terms of x with dx, you want a terms t with dt. So make a cross multiplication here. It will be 1 minus kux into dx, and it will be u dt. Okay, because this is now a separable form, so I can integrate both sides. Okay, integrating both sides. Okay, I'll integrate here. 1 with respect to x minus ku can be taken outside, and it will be x dx. From here u can be taken outside, it's a 1 dt. Okay, you know, integration of 1, it will be x ku, integration of x will be x square by 2 u, and integration of 1 with respect to t, it will be t, and I can place another constant b. And you know what is b here? B is another constant of integration, and its value can be found by using initial condition. Okay, I can call it equation number 2. And what I say here, that b is a constant of integration. Okay, here b is constant of integration. B is a constant of integration, and its value can be found by using which things? By using initial conditions. You know, initial conditions. Initial conditions are at t is equal to 0, x is 0. So I'll put x equal to 0, x equal to 0, t equal to 0, and I hope so I'll be getting b equal to 0. Okay, what I have to do here, I'll put at t equal to 0, x is 0. So I'll put these values here, x equal to 0, t equal to 0. This will become 0 minus 0 equal to, and if I put there here t equal to 0, this is 0 plus capital B. So you'll be getting capital B equal to 0. So I got capital B equal to 0. Now, capital B equal to 0, I'll put this capital B in equation 2. Okay, put capital B equal to 0 in equation 2. Okay, if I will put the x minus k u x square by 2 equal to ut plus b equal to 0. So b is 0. What do you want? You want a t here. So what I have to do? Okay, one thing you have to do, just take LCM here. If you want a t, ut, its LCM will be 2. 1 here divide 2, 2 will multiply with x. 2 here divide, it will be kux. What do you want? You want a t. And how we can get a t here? T can be get. Okay, let's see here. U is multiplying. U will come here and it will divide. It will be 2x minus kux divided by 2. This u will come here. It will become 2u. So this is which thing? You go to t. Two things you want. You want a v? Yes, I got. And v in terms of x. Second thing you want a t? I got a t in terms of x. So I got both things. And in V, there is U, no issue, because it's given in the question that its initial velocity is U. And in T, there is U, because I got a T in terms of X, but there is U, no issue, because in the question it's given that initial velocity is U. So no issue, one thing is given in the question and it is coming in the answer, no issue. So it's okay, we got a velocity and time. So that's it for the time. Goodbye. Allah.